All right, welcome to class, everybody. Our lesson today is section 7.2, and we're going to be talking about exponent rules, specifically about how they apply to roots. Because our last lesson was all about radical expressions, which are basically expressions that have roots in them. And remember that roots and exponents are opposites of each other, kind of in the same way that addition and subtraction are opposites and multiplication and division are opposites. So we mentioned this a little bit last class, but I want to kind of reiterate it. So whenever you're talking about roots, you can use exponents to represent the roots. So if you see 81 to the 1/4 power, what this means is that you are doing the fourth root of, 81. That makes sense? So if you have a fractional exponent, the number in the bottom of the fraction tells you what kind of root it is. So in this case, what would that simplify to? Yep, it would simplify to be 3, because if you do 3 times 3, that's 9, times 3 again is 27, times 3 a fourth time would give you 81. Now, we haven't done any exponential or fractional exponents like this one, but basically the bottom number of the fraction will be the root, and the top number just works like a regular exponent. So you can simplify these ones in two different ways. You could either do the cube root of 64 squared, or you could also do the cube root of 64 and then square the result. Either way will give you the same answer. I personally prefer to do it this way just because it will be easier to find the cube root of 64 versus like if you do 64 squared, you're going to get some number in the thousands. It'll be a little bit harder to find the cube root of something that's in the thousands. But if you do it either way, you should get the same answer in either case. But I'm going to do it this way and say, well, the cube root of 64 is 4, because 4 times 4 is 16. If you multiply by 4 again, that gives you 64. So this part equals 4. And if I square 4, that will equal 16. And you would get the same answer if you did it this way. You'd get whatever this thousands number is, and you would find out that 16 times itself 3 times would equal that number in the thousands. All right, so any questions on this so far? Okay, so that's our first exponent rule. You can write roots as fractional exponents. The next type of exponent rule we're going to look at is negative exponents. So if I was trying to figure out what 5 to the negative 2 is, the negative sign basically creates a reciprocal. And the reason for that, I'll show you kind of the rationale behind this. So if we took 5 to the third, 5 squared, 5 to the first, 5 to the 0, 5 to the negative 1, 5 to the negative 2, etc. We know what some of these powers simplify to. Like we know 5 to the first is 5, 5 squared is 25. What is 5 cubed? Yep, 125. And if we look at these powers that we know, what's the pattern as you go down? Yep, so it is descending, it is going down. And what is specifically the pattern? Like how would you get from 125 to 25 and then get to 5? Say it again, I think I heard some. It'd be what? Yes, perfect. And what are we dividing by? Perfect. Yep, because if you divide by 5, that will give you the next result, right? Which makes sense because the way that we found 125 was we took 5 times itself 3 times. Well, 5 times itself 2 times is going to be divided by 5, like that result divided by 5. And so this shows us why anything to the 0 power equals 1, because we've talked a little bit about this before, but this is the reason why. Because if you take 5 and you divide by 5, you'll get 1. If you take 1 and divide by 5, that will give you 1/5. If you take 1/5 and you split that into 5 pieces, that will give you 1/25. And so basically, whenever you have a negative exponent, you just do the reciprocal of the positive version of that exponent. So like when I'm doing 5 to the negative 2, I want to think about it as 1 over 5 squared, which simplifies to 1/25. So negative exponents create reciprocals. And that's true even if you have a negative fractional exponent. So if if you were simplifying something like this, the way that you would do it is you'd say, okay, well, the negative exponent creates a reciprocal. So I'm going to have 16 over 9. That's going to take care of the negative part of my exponent. And then the 1/2 tells me that I'm going to have a square root, because the bottom number of the fraction tells you what type of root it is. So you do the square root of 16 over 9, which would equal 4/3. And that's how you would simplify that. Okay, any questions about negative exponents? All right. Okay, so fractional exponents make roots, negative exponents make reciprocals. And then the next thing we're going to do is simplifying powers that are multiplied together. So x to the 3rd is a power because you have a base and an exponent. X to the 5th is another power that has the same base and an exponent. So if you multiply two powers together that have the same base, there's a really easy way to simplify it, because what this means is that you have 3 x's multiplied together, and that's multiplied by 5 x's. But everything's being multiplied, so those parentheses are not really particularly useful, so we could just erase them. And how many x's are there altogether multiplied? 8. And what pattern do you guys notice between these two exponents and this exponent? Yep, you just add them together, which makes sense because you had 3 x's multiplied. You're like kind of adding 5 more x's that are multiplied, and now you have 8 total. So whenever you are multiplying two powers together, you can add their exponents if they have the same base. If one was an x and one was a y, you couldn't simplify it at all. But since they're both x's, you can combine them that way. And that's true even if you have fractional exponents. So if we have something like x to the 3/4 and x to the 1/4, you could think through it and say, well, this means that I'm doing the 4th root of x cubed times the 4th root of x, and try to simplify it that way. But it would be even easier just to use this trick that we learned here, where you can add the powers or the exponents together. And 3/4 plus 1/4 is 4/4. So you'd get x to the 4/4 power. Well, 4/4 simplifies to just be 1. So you'd get x to the 1st power, which is just x. And you would get the same answer here because this is actually the multiplication rule that we learned last class. Because if you have 2 roots that are multiplied together, you could combine them into a single root, kind of undoing what we did last class. And you'd have the 4th root of x to the 4th. Well, the 4th root of x to the 4th is just x. So you get the same answer either way, but I think this method is way easier. Any questions on multiplying powers? Okay. The next exponent rule we're going to do is dividing powers. So if I had x to the 3rd divided by x to the 5th, this would mean that I have 3 x's divided by 5 x's multiplied together. And the 3 of the x's are going to cancel out, leaving me with 1 over x squared. Now, we know that reciprocals can be written as negative exponents. So you could also write this as x to the -2. So when you look at that exponent and compare it to our original exponents, what pattern do you notice? Yep, it would just be subtraction. So 3 minus 5 gives you -2 as an exponent, which you can write like this. And this will work even if you don't end up with a negative number. Like, for example, if you had, I don't know, something like x to the 9th over x to the 5th. Well, this would be like 9 x's on the top. 5, 6, 7, 8, 9. I think that's 9 over 5 x's. And if you cancel out all of the x's that you can, you notice that you do end up with 4 x's on the top. So it kind of depends on whether your top exponent is bigger or smaller, whether or not you'll end up with a negative exponent. And on your homework, they ask you to always write your exponents as positive exponents. So if you get this as an answer when you subtract, you need to write it like this, otherwise your homework won't accept it. Technically, they are both correct and they're both equally correct, but your homework wants you to write it with positive exponents. So you would write it like that. So you can also do this even if you have fractions. So if you had this expression here, you could just say, well, 3/5 minus 4/5 would give me x to the negative 1/5, which for your homework, you would write it as 1 over x to the 1/5 so that you have a positive exponent. And also, I didn't do any examples of this, but if you ever have different denominators, then you would just need to find common denominators and then add and subtract the fractions together. All right, any questions on that? Okay, so the last exponent rule we're going to do is when you raise a power to an exponent. So if I had x to the 5th raised to the 3rd power, what this means is that I have 5 x's multiplied together, and that is multiplied by itself 3 times. So it'd look kind of like that. Now, how many x's are there? How many? 15. So what do you guys think the pattern is when you raise a power to an exponent? Yep, you just multiply the 2 exponents together because you have the base raised to itself this many times, but then you're raising that to itself this many times. And so you multiply it to find the total number that you're raising it to. And that's true even if you have fractions. So if you had x to the 2/3 raised to the 1/2 power, you would write this as x to the 2/6, because if you multiply 2/3 times 1/2, that gives you 2/6. So remember, when you multiply fractions, you just multiply the top and the bottom. If you add and subtract fractions, you need to find common denominators and then only add or subtract the top. Yeah. Oh yes, this one, yeah, this could simplify. So this would be x to the 1/3. Yeah, because 2/6 and 1/3 is the same fraction. This is just the reduced version of the fraction. Yeah. Yeah. Any other questions? Okay, so you have 5 exponent rules. The first one is fractional exponents create roots. The next one is negative exponents create reciprocals. If you multiply 2 powers together and they have the same base, that is really important. They do have to like both be x's or both be some number. But if they have the same base and you're multiplying them, you can add the exponents together to simplify. If you're dividing, very similar, they have to have the same base, but you can subtract the exponents. And then if you raise a power to an exponent, you can multiply the 2 exponents together to simplify it. Now, on this one, you can get some more complicated problems than just like this. You might see something that looks kind of like this. So if we had x cubed y squared z to the 4th to the 3rd power, what that means is you have 3 x's, 2 y's, 4 z's, and that is multiplied by itself 3 times. I'm glad I chose little numbers because that is helpful. So if you multiply all of that stuff together, how many x's are all multiplied together? 9. So this is going to be x to the 9th. If you multiply all the y's together, how many will there be? 6. And if you multiply all the z's together, 12 of them. So you might notice that this is that same multiplication pattern, but it's kind of like this exponent is being distributed to all the other exponents. Now, this is different than the distributive property of multiplication over addition, which is what we usually call the distributive property. And I don't actually even know if this is called the distributive property of exponents, but to me, that's what I call it because it's very similar in structure to the way that it works. And you can do this even if you have fractions, like you could go 4/5 and multiply it by each one of these exponents to simplify it. But I want to emphasize something really important if you do decide to call this the distributive property, and that is that you can distribute exponents across multiplication, and you can distribute multiplication across addition. But what you cannot do is distribute exponents, across addition, because this does not equal x squared plus y squared. And we know this from working with polynomials so much, because if you FOIL this out, what you actually end up with is x squared plus 2xy plus y squared. And so you can't just distribute the exponent to both of the terms. So kind of the way I like to think about it is like the way math is built is you have addition, then repeated addition is multiplication, repeated multiplication is exponents, and multiplication can distribute over addition, just like this. And exponents can distribute over multiplication like we saw here, but you can't skip a level and have exponents distribute across addition. Is everybody good with that? Okay, so that's actually it. Those are the only things you need to know for the lesson. So you've got negative or fractional exponents make roots, negative exponents make reciprocals. Multiplying powers means you can add the exponents together. Dividing powers means you can subtract them. And if you have a power raised to an exponent, you can multiply the exponents. And you can distribute it if you have multiple things raised to a power. So I'll let you guys get started on your homework. If you have any questions, let me know. I'm also happy to help with any questions from previous lessons, if that'd be helpful.